Hi, I'm Yi Hangzhou. Here I'm going to share some knowledge about how to remote debug Linux file system. Now I'm going to download and compile Linux kernel source code. First, install all necessary components. Then download the source code. Now the source code is already done. Download it. First, we need to copy config file from boot directory. Then we need to modify the optimization in makefile. Okay, here I already modified. Replace the original optimization O2 with -G and -OG. There are three places we need to do the replacement. Okay, next step is make -G. Okay, the number follow the letter G is the number of your processor. Okay, the source code file was compiled done, and now I'm going to create a clone for this virtual machine and make it as the debug target. Okay, the clone process is done. Now you can see there are two virtual machines. This one will work as a debug target. This one is the host side. I will use the debug remotely connect the target machine. After creation of the target virtual machine, you need to boot up the target machine and enter the compiled source code directory. Then execute the following command line to apply the new kernel. Okay, now after the new kernel installed, check with this command line to make sure the new kernel is installed correctly. Now I'm going to edit the series port for both virtual machine host side and the target side. And as you can see, let's edit the series port for host side first. Remember, select this as this virtual machine, this site as a client side. Next, edit a serial port for target site. Okay, remember set as service side. The next step, we need to put up both of these two virtual machine, and I will teach you how to detect which series port currently both this system is using. Now both virtual system are boot up. This IP address is belong to host site, and this IP address is belong to the target site. Okay, let's now I'm going to determine which serial port device name I should use. Okay, let's test the TTYS0 first. Execute this command on the host side, and in the target side we execute this command to send some characters while TTYS0 to host side. See what happened. Okay, done. The host side received what we sent, received the data what we want. Okay, so it means both virtual machine are using TTYS0. Now I'm going to modify the boot up parameters for current kernel. As you can see, make sure you use correct serial port device name, and save and exist. Okay, done. Reboot. Now what I'm going to do is execute this file. There are 3 lines in this file. First it will activate the kgdb, and if on the host side the kgdb is waiting for the connection, and this line will trigger the connection. And the third one is very simple example file. In this executable file, it will read 1.txt. Let's take a look quickly. As you can see in this a.c, first it will try to access a file. The file name is installed, is referenced by pointer fx. Actually, this file is not exist. It's just for debugging purpose. Okay, the real open function the real open function is here. Okay, let's execute this file now. First, execute this file. It will immediately stop the current target virtual machine system because it will waiting for response from the host side. Okay, it's stopped. Now I'm going to execute kgdb on the host side to accept the connection. Okay, as you can see, there are series. If you can see close, you can see many. There are several watch point set, and after the watch point triggered, it will set another watch point, and after this watch point triggered 1, 2, 3, 4. After it was triggered 4 times, at the I'm sorry, five times, it will added another watch point. Then it will break. It will triggered at another place. Now in this place, we can see the call stack from the top f open file to the lowest position which is within ext4 file system. With this call stack information, we can be told how Linux file system process file path for the fopen function and the detailed implementation for the whole process. So it's pretty clear, right? Thank you for watching.